to the screencast session on week 2 merge sort. So we are implementing two functions for this merge sort algorithm. So basically the merge sort algorithm follows the divide and conquer policy. So hope you know that. So in this first we are implementing that merge function. The merge function job is always compare the two lists and the smaller element is going to be merged. So we have divided that the merge function into the different cases. Similar way, the merge sort function we are dividing into the base case and recursive case. So we are implementing the first function is that the merge function. So let's implement this. So we are writing that ref the merge function which takes that two parameters of a and b, which is the two lists, and initially we are having the two list size, that is m and n, which you are getting that. So the length of the a and the length of the b, both of them we are getting. So then we are taking a merge list into the C, and to track that index positions we are using that I and j. C it contains that empty list, and I and j it contains that 0 as initialized. So then we are going for that first case. So we are trying to compare. So the each element of the two lists, like while the index position of the first list, that is size of m, and the second list which is that n, until they are ended we are trying to merge. So let's merge that. If that element of I is smaller than or equal to that element of the b, which is that second sublist. If it is, then we are trying to append into that. So smaller element with C. So this A value is going to be merged into the C. So I think there is a indentation issue. Let's move. Yes. So hope it's okay. So now this is fine. When that the incrementation of that I is increased because that element of the A is added. If the other case where that B element is smaller than that A, so then we are trying to append that B element into the merge list C, that is J, and we try to increment that index position that is belongs to that B. So this is that first case we have implemented. So let's implement the second case, because there might be that list A is still remaining but list B is over. So then what should I do is the remaining list of that A is going to be added, that is I less than up to the M, which is the size of the A list. We are trying to appending into that all elements from the A. So it is incrementing the each index position of the I. So if this is the case that whenever that list A is in bigger size, so maybe you have another case, then maybe the bigger size of the B. So then what happens, we try to add the remaining elements of the B into the C, so that C dot append, we are getting the list from that B, each element of the B we are storing. Let's increment that J index position. So finally we got a merge list into the C, and we try to return it, just return that C. So the complete C is having that the sorted list of comparing that A and B, that's done so far. So now we are going that the calling function, that is the divide and conquer policy which we are doing in the merge sort function. Let's implement that function. So it always will do that divide and conquer policy. Let's implement that. The merge sort function def the merge sort, which is recursively you are calling it, so which it takes that list as a parameter. So this list we are having that the length of the list we are tracking it. So by using that n equal to, so the length of the list, and then we are trying to check the different cases. Generally the recursion will stop with the base case. So let's implement the base case. So whenever one element or none element is there, let's do that. If my size of this list is that less or equal to 1, just simply we return whatever that list existed as it is. So and now we are doing the divide and conquer policy. So that's called general case 1. So we call it we are trying to do that recursive call on the left partition of the list. So let's do that. So left equal to, so merge sort, recursively we are calling. So which you are sending that the existing list, and we are using that, slicing of it, which is, we are saying it is general case 1. We are getting that, left partition of the list. That left partition we got it into the left, and similar way we try to do that another general case which is called recursion call, that is right partition equal to the merge sort, that is, we are trying to get that right partition, that is splitting of the list, slicing of the list. So we got the right partition of it. So once we got that left partition and right partition, which is that, continuously as small as such, so we are getting a sorter list which is called SL by doing the merge operation, by comparing the left of partition and right of partition. While they are merging, they try to compare these cases, so whether that first sublist element is smaller or second sublist element is smaller, so these operations are compared and they are merged. So that is continuous job it will do by taking that left list as a parameter and the right list as a parameter. Of course, these two we are sending as a parameters which is received as that A and B, and they are merged. While they are merging, they are sorted. And finally, we got the sorter list that's written SL. So it is done so far. So let's run this one. So sorry, we entered into the Python compiler. Let's exit from this. So let's run this code. We are saving in the VS Code, and let's run this. So hopefully that no issues in your algorithm. Let's do the input and we try to do that. We are writing the main function here. So simply we are trying to have a list of that and we are trying to sort it. So I'm taking a constant list. Let's have that constant list is that this 89, 4, 17, 34, 3 and 1. So this is the list. I want to sort it through merge sort. So let's call the merge sort. And we are calling the sending of the list as a parameter. So by that we are getting a sorted list as a return value. Let's print that. The sorted list is here. Yes. So our input list is this in the 53 line number and output list is that 55 line number. Let's run this one. So we got the sorted list 1, 3, 4, 17, 34 and 89. So we done that merge sort. So thank you very much for watching. Have a nice day.